Okay, so let's take a peek at our assignment. So assignment number 3 for rolling contact bearings. It's going to be found here. We're going to click on the assignment sheet and it's going to identify the problems that you're going to be doing. So these are found at the end of the chapter, starting on page 587. And it says here, use the Excel spreadsheet where applicable. So as we look at those problems underneath, so problem number 2, determine the required basic dynamic load rating for a bearing that is carrying 1250 pounds from a shaft rotating at 880 RPMs if the design life is 20,000 hours. Now, you could use the spreadsheet if you wanted to, all right? Or you can do the hand calculations. This is like example 14.2, okay, 14.2. The next one here is the catalog lists the basic dynamic load rating of 3,150 for a rated life of 1 million revolutions. What would be the L10 life of a bearing if it is subjected to first 2,200 pounds and then 4,500 pounds? So one is going to be less than what that basic dynamic load rating is, and one is going to be more. This is going to be like example 1, but you're going to work it two times. This one does not go with the spreadsheet at all. This one would be a hand calculation. And then I have 4 crossed out, but I also have it highlighted. So I wanted to check. I do have 4. Okay, you're getting 4. It says here, compare the rated basic dynamic load rating, C, for a ball bearing to carry a radial load of 1,450 pounds at a shaft that's rotating at 1150 RPMs for an industrial fan. Now, industrial fan means that you need to look on that table for the design life that would be appropriate. So on page 575, you're going to find, where do you think an industrial fan is? And then you're going to pick the number of hours. Now, remember, they're giving a range. So you're the designer. You get to pick within that range. Okay, as long as it's reasonable. So if it's I don't know what it is. If it's the 20 to 30,000, you know, you can pick 20, you can pick 30, you can pick something in between. Okay. So, so that is that problem. And then you're just gonna calculate, I think it is the basic dynamic load rating. That's what you need for that one. So that's similar to 14.2. Then our next problem is number 9, 10, and 14. So let's look at 9, 10, and 14. So number 9, it says we have a bearing is carrying a radial load of 455 pounds, no thrust load. Specify a suitable bearing, not from the tables in the book. You want to use the catalog pages that we just used, for example, 14.3. Okay. The shaft rotates at 1150 RPM and the design life is 20,000 hours. Now, it doesn't ask you for the mounting information, but I want it. Fill in the entire portion at the bottom, the pink portion at the bottom, sizing a bearing and identifying the limits for the shaft and the housing for this one. Okay. And then you're going to repeat problem number 9 for 10 and 14, I believe. I've got things crossed out. Yeah, 10 and 14. 10 and 14. The Excel spreadsheet? You know what? You decide. You decide. I'll let you decide. Look at the problem, see what the Excel spreadsheet offers you, and see if you want to use it. All right. They're not complicated equations. You really could do them all by hand, but what's nice is if you do it by hand, make sure that you include the stuff on the bottom. Okay. Now, for numbers 4 or 2, 3, and 4, it's not asking you to size a bearing. It's not asking you to pick one. So you don't need to use the pink section down below. Does that make sense? Because it's asking you in these problems, what's the dynamic load rating? What's the dynamic load rating? And what's the dynamic load rating? So they're not asking you to size, but 9, 10, and 14, you're picking a bearing and you're using the catalogs, and I want to see mounting stuff for you from the back. Okay, fill in all the pink at the bottom, even though the book's not asking you for that mounting information. That's critical. You're the designer. You've got to incorporate it into your design. That's like the logical next step. Okay. All right. Now for these problems, you're going to notice that they don't give you a shaft diameter that you have to meet. So you're just going to do it on the life. Or the loads. You're only going to do it on radial and dynamic load rating. Okay. You don't have to worry about what is the size of the shaft. You'll get to, don't worry, in your gearbox design. But for these, just making sure that we know how to size them using the catalog, calculating those values for radial and dynamic load ratings, being able to pull off the charts, and then get the appropriate mounting information. Okay. Any questions at all at this moment? BJ.
So, notice, for the example problems of module 3, it asked us, the questions for like multiple,
Okay, yeah, so going back to the practice problems. Okay, yeah, let's take a look at the practice problems. So that's assignment. So no questions on the assignment though, before we go backwards? Not backwards, I don't mean it that way. Go to the other one. Okay, then let's take a peek at the practice problems. Good. All right, so, oh, I did. Okay, well, let's use our thinking caps. So probably, what are 2 facts you learned about bearings today? Thank you, BJ. You caught me copying and pasting. Yeah, thank you for pointing that out. I will get that updated. And so for module 3, yeah, don't forget about those little questions. I really like them. You know what? This is new to me. This was a suggestion that I learned in some training that I did, and I never had done it before. And I actually look forward to seeing your answers for those questions. So I hope they're not painful for you. Remember, it's not about, doing a lot of, digging and researching. These are like, I just want to know your thoughts. Okay. Yes. What are 2 facts you learned about bearings today? Any other questions or issues? Okay. So then I'm going to stop recording. That should be all set there.